And this guy just says it becomes redundant. So now we got two if statements. And our execute statement is bound to get a little complicated over time because it's also an algorithm. And I've been saying that quite often, and I'm trying to hammer home this idea that anytime you have an algorithm, you've got a chance to refactor, and you've got a chance to optimize, which is the more, I guess, more important term. You can always optimize a algorithm. Anything that makes a decision can always do it more effectively, or do it in a way that covers more cases. So when we look at this, it looks very scripty, right? It's got some if stuff. It's got a switch statement. These are all our decision trees. And decision trees can get really complicated really quickly, so it's always good to come back and say, what am I repeating? What can I switch down? What's needlessly complicated? Okay, so, but whenever you go to execute a command in the game, we're first going to check to see if you're in play. And if you're in play, then you can go ahead and execute. If one of the parties is out of play, we're just going to return back and say, hey, sorry, the thing you wanted, the person you were trying to target, or you yourself are out of play. All right, so we're still mixing in the game, so the game state and the state pattern into various places. Let's go back over to our actor. All right, so we're going to follow that same idea here, and we want to check to see if the player is alive or dead before we do anything. Thinking about that, I don't want to do that here. Thinking. Let's go back over to our hive mind. Okay. Let's make this a part of our command pattern. So we're stepping away from the state pattern for a second, going to our command pattern, which has to do with our request and our response. So when we did our command pattern, we decided that, hey, everything in the game should have a execute. So let's also make a check state. Sorry about that. I'm wearing this shirt and the microphone loves to fall off. I used to laugh watching TV or like the news or whatever and seeing people that would have mics but like all this tape on it. And I was like, what is that, man? Get a proper something. I think you have a choice sometimes. This shirt is an edge case. Okay. So I'm going to give everything the ability to check state. So if I go to build now, I'm going to have 6 errors because I've added something that needs to be inherited to, in a base class. And so everything that's inheriting that hasn't implemented it is saying, whoa, I am now out of spec. let's go into player first. And so player inherits from base actor. And so does monster, right? So we can get two birds with one stone by saying this here so it's a little clearer. Public override. And then Resharper is really good about saying, hey, what can you override? Blah, blah, blah. Oh, hang on. And I just want check state. Okay, so then here, and I want to see if we're alive or dead. That's kind of the idea, if I didn't make that clear. If this dot hit points are less than or equal to 0, this dot game state is equal to game states out of play. This dot actor state is equal to actor states at dead. And so this guy is telling me that this is redundant. It's really a style choice. I've always said, hey, if Resharper tells you to do something, always question it. I think in this case it's a little more clear. It also says, hey, invert the if to reduce nesting. I'm just going to show you this. If you don't have Resharper, these are the kind of things it wants to use to jockey your code. So it wants me to do this. If this is not equal to hit points less than or equal to 0, just return early. So what it's trying to do is get me to bail as early as possible. One of the base tenets of optimization and algorithm is don't do any processing you don't have to. At the earliest opportunity, exit out with a good value, right? That's kind of what you're always, if you know nothing else about writing algorithms or doing some advanced math or like really optimizing code, you know that one thing. The sooner I can get a good value and exit out, the better off we'll all be. All right. I don't want to do that right now because there's no real need. I'm just setting things. If I was doing a bunch of instantiation of things and I had multiple cases, this is a pretty substantial algorithm, I definitely would do that. Okay, so now I can check the state and I can say, hey, if the hit point's less than or equal to 0, then I will do this. And I'm doing that because inside of my hive mind, when I get like a heal, so the sender executes their request. So the sender, for lack of a better way to express this, if you were like in a kind of an RPG and you were like a spellcaster, so the first thing the hive mind said says, oh, you want to heal? Let me roll and see what your heal is. And so goes to the sender and says, hey, cast your spell. And the sender says, okay, I cast the spell for 10 points of health. And then the hive mind says, okay, target, you now get 10 points of health. What we're not doing here under restore health is we aren't checking to see what that would have done to the player's state, right? So if the target takes damage and their damage goes below 0, there's nothing, right now they're still alive, which would be wrong. So for that and any other case that we might have, we're going to want to check the state afterwards. For our game, that's going to be alive or dead. We're also doing a zombie game. So we might also want to say, hey, check the state. If this person's now infected, do some other things, right? Maybe reduce their intellect by 20 because they're infected. Who knows? Maybe make them angry. So we want to have that ability. So we've overridden the check state there. Let's see where else we've got to override it. All right, in the non-player character. So our NPC We also have a base NPC. We just don't call. Or I'm sorry, we got an NPC that operates as a base NPC, even though we don't call it base NPC. So our non-player characters are things that we want in the game. We want them to kind of look and feel human, but they've got so many other things they can do. They can respond to quest statements, right? They can play roles that are very different from monsters and players. So, but inside of our base here, we've got game response execute not yet implemented. We're going to do the same thing for check state. And you can really see where writing a game, I mean, it could be what you do every day after work or school or whatever in your free time, because there's always so much to explore and so much to do. We're using it as a learning example, so there are going to be some places where we don't quite deep dive into the nitty-gritty as much as we might like, and here's one of them. But if we keep going, eventually we'll get to all these little spots. All right, so now that we've got that implemented, it succeeds. So now in my hive mind, after every command that comes in, I'm putting it onto the response stack, so I've got an active record of all things that happen in the game. But then here, I also want to do a sender. Oh, hang on. Alright, so I don't have access to check state here. Let's go through and kind of see why I don't have access to check state. I just put it in the base game object, so why don't I see it here? So I go to my game request. Oh, so we've got the iGame object is what our sender is. And inside of our iGame object, we did not describe that. I don't know if describe is the right word, but essentially, when we have this contract, we say, hey, this is going to be an iGame object, we're telling .NET that, hey, for this interface, you'll only have access to these properties and methods, regardless of what actually exists on the implementing class. It'll at least be this, and you'll only have access to this. This ends up being a good way to hide things if you're doing an API. It allows you to do things like the facade pattern, which we haven't gone over yet. But if you've got 50 methods and 50 properties in a class, and you want to expose just 4 of those to an API, you can do it this way. You can say, hey, you have access to the interface, whatever, it has these 3 things. And you also notice because of that, when I'm in here, I get no IntelliSense. This thing knows nothing about base game object. So void check state. Okay. Hang on. So the question then becomes, do we want check state a part of this interface?